Now imagine that this is not there. Just try to think in this way, guys. Imagine that this layer is not there. Then what it tells? It is as simple as logistic regression. That now all these lines directly go to your for predicting your output. Yes or no? Is it as simple as your logistic regression? And I'm not taking a logistic regression loss function here. I'm just trying to come up with an analogy with linear regression in terms of, because we have not learned the log loss function, the loss function for logistic regression. I'm just taking the analogy only with respect to loss function. Just consider the analogy for only loss function now. So in linear regression, what was the loss function? Mean square error, mean absolute error, something, something. And then what we used to do, we used to find the derivative of this loss function with respect to beta naught and then beta 1. And this derivatives, using these derivatives, we used to update our beta naught as beta naught minus or plus, it doesn't matter, learning rate into d loss function divided by d beta naught. Beta 1 is equal to beta 1 minus alpha dl by d beta 1. Do you remember this gradient descent for linear regression? So in that case, if you remember, we have started with some random values of beta naught and beta 1. We have started with random values of beta naught and beta 1, calculated loss values, found the derivative of loss function with beta naught and beta 1, and then we have updated beta naught and beta 1, right? Again, with the updated values of beta naught and beta 1, we have calculated the loss function. Again, we found the derivative of that. And then again, we have updated beta naught and beta 1. Okay. This is called as gradient descent method. Okay. Using gradient descent method, we always try to achieve or minimize the error. We try to minimize the loss function. Okay. In linear regression, our loss function was mean square error or mean absolute error. But in logistic regression, we have a loss function which is something else. For time being, assume that is a log loss function that we'll be seeing in the next course. That is called as log loss function. But the methodology in logistic regression also is same. It is same. What we do in logistic regression is we derivate and then we update the parameters and then we calculate the loss function. Again we derivate, we update our input fee, we update our parameters, and then again we calculate the loss value. So the way of doing gradient descent is same. Did you understand this? See, the function, the equation might be different. In linear regression, it is mean square error. Here it is some other expression. Don't worry about that. But did you understand the steps of gradient descent method? Right. Similarly, here also, we actually randomly gives our initial weight values would be decided randomly. This value would be decided randomly. And then this, what we are trying to do here, finding the derivative and then updating our beta naught and beta 1, and then again calculating the loss value, and then again taking a derivative of this, and then again updating your beta naught and beta 1, is you're trying to always go back and correct your beta naught and beta 1, right? In linear regression or logistic regression, like you're correcting your weights indirectly. So this going back and correcting your weights is called as backpropagation. Okay. Similarly, here we start with some random values of weights and then we calculate the error and then using derivatives, and then we go back and then we correct our weights. So in logistic regression, you had the opportunity to correct your weights only one time, with many iterations of course, but then you have to correct it only like this, right? From output to your input layer. But if I bring in one additional layer, now just imagine I'm just bringing one additional layer. So now what I'm trying to do here is I'm doing the back propagation 2 times. So I'm correcting my weights again and again. When I correct my weights again and again, what happens? The accuracy of the model would be quite high. That's a simple concept which I'm trying to explain. When we do not have this yellow color layer, which is hidden layer, we generally what we do, we calculate Z as WX plus B, and then we calculate the probabilities using activation function. Let's, in neural network language, it is called as activation function, which is 1 by 1 plus e power minus Z, right? But instead of doing this at taking this input features and then directly going and predicting your output, what I am doing, I am incorporating one additional layer with some more features, and now those features are called as A1 for layer 1, A2 for layer 1, A3 for layer 1. Initially we had 4 features, now we have 3 features in this layer. Okay, now with this W1, W2, W3, W4 with suffix 1, we calculated first Z1 and then we have calculated A1. Similarly, with W1, W2, W3, W4 with suffix 2, we have calculated Z2 and then we have calculated activation function 2 for layer 1. Similarly, activation 3 for layer 1. Now this A1, A2, A3 will be used as input features. Okay, and then it will use for your prediction. It will be used for your prediction. Instead of going in logistic regression, it was only one layer. Now we are having, in logistic regression, we had only one layer, right? Input to output. So directly output was A suffix 1. But now we have 2 layers, which is one hidden layer and one output layer. So in this way, we have got more opportunity to correct our weights so that our prediction is even better. That is why we are using this neural networks here. Don't worry about the maths now, but did you understand the concept? That's what my main aim here. We'll see the maths in the next session, in the next course, and then we'll see this back propagation. There will be a lot of maths, okay? So please be prepared for that. The architecture which I've shown with one hidden layer, in reality, there can be lot of hidden layers. So there can be different architecture. And how does it looks like? I've taken some examples here, okay? This is called as single layer feed forward network. This is called as single layer feed forward network. So there is no hidden layer. That is the reason it is called as single layer, and you have multiple outputs. You can have multiple outputs. In logistic regression also, if you remember, we can have 0, 1, 2 as our classify outputs, 0, 1, 2, 3 also. So based on that, similar to that, okay? So this is called as feed forward because we are going from inputs to output. That's the reason it is called as feed forward. Now the example which I have taken with hidden layer is here. This is called as multi-layer feed forward network. Here what we are trying to do is, for these input layers, these are the output, but your final outputs are here. So for this outputs, final outputs, this hidden layer would be considered as your inputs, okay? So now you have the opportunity of correcting your weights additional time using hidden layer, right? So that's a reason we always, like the ones with the neural networks with having some hidden layers would be having more accuracy rather than having 0 hidden layer, okay? And now there is something called as third one is single node with its own feedback. So what happens, you have some input and then you want to predict the output. Your output values, based on the output values, you will get the feedback on the input. We give that feedback to your input and then we try to correct the prediction, okay? And similarly, we have single layer recurrent network. For example, these are our inputs, these are our hidden layers. Oh no, sorry, these are not hidden layers, these are our outputs Y, and then we are just recurrenting. That means we are giving the feedback of that to its We're giving that feedback to its own layer so that we can correct the output. Okay. And then here, similar to that, in the multi-layer recurrent network, we are giving the feedback again back to its our node. So don't worry about recurrent network. Okay, don't worry about recurrent network. In our advanced course, we will be learning this multi-layer feed-forward network. That itself will take around, that complete course will be on this multi-layer feed-forward network. Okay, don't worry about recurrent network. And again, because there are a lot of different architectures in outside world, okay, and there are some more neural network architecture which is called as convolutional neural network. In recurrent neural network, you are giving the feedback and then you are just trying to come up with a better solution. In there is something called as convolutional neural network again, which is highly recommended for image processing or object detection problems. But then again, that is not designed for the course. We will be looking only for, there is one separate course which will be looking for where we'll be looking only feed forward network. Okay, so coming back to our basics, what we do is we import the libraries in Python, we import the data set, we split our data set, and then we train the model with the training data set. We run the predictions on our test data set, and then we check our validations, right? So this is how we work. Okay, I'm just trying to repeat few things how we work in a machine learning project. But here my only objective was to explain that instead of using single layers, which till now we will working with only single layer, right? But this is a single layer feed forward network. So but in future, when you use multi-layer feed forward network, it is called as deep learning. So you have deep models, like you are coming up with lot many layers. Okay, you can always increase these hidden layers. If you increase the hidden layers, it is generally called as deep learning model. Okay, and that is also an advanced machine learning model. Okay, so our third course would be completely on deep learning, multi-layer feed forward network. Okay, so I want to repeat few things again, which would be again useful for this complete first course, which I've already told this. You have to follow whenever you get a new project, you should always follow this cycle in the clockwise. And also in this, before splitting the data set, you should do exploratory data analysis also. Okay, you should always do exploratory data analysis. Don't forget to do that. Okay, but then deep learning will be really helpful because your computer train itself to process and learn from data. Okay, so deep learning is very highly advanced machine learning model which we'll be learning in the coming course. But I'm happy if you can understand this feed forward network itself. If you can just understand feed forward multi-layer network, which I've explained now, if you can understand that, I will be really happy with single hidden layer also, because anyways our deep learning course is designed with more number of hidden layers. So at that time we can look into that, but it's similar. You would have one more hidden layer inside, and then here we are looking with a superscript 2, there will be a superscript 3, a superscript 4. So that would be more challenging and you will see a lot of maths in that. Okay, but you don't have to worry. If you can understand the concept, that is fine. Now you will understand the maths in next session, in next course. Okay, so please always remember this cycle when you are working on machine learning project. With respect to Python or any other coding language, I don't mind, but always remember this cycle. Import the libraries, then import the data set, do exploratory data analysis, and then split the data set, train the model, and then predict using test data set, and then check the score. Okay, finally I would like to tell few more things with respect to classical machine learning and deep learning. Okay, few differences in this two, because why people are moving towards deep learning. Okay, so in reality what happens, we will have a lot of data. So when we have a lot of data, more the data, better the prediction, right? Because it will be useful for predicting our output if we have more data. right? So in general, if we have more data, we should try to use deep learning rather than classical machine learning, because if we have more data and if we use deep learning, you would get better accuracy. Okay, that's the first thing. Now, what is this training, dev, and test data set? Instead of splitting the data set into two and splitting the data set into three, it's okay if you split into two, don't worry about that. If you still split into two, 60-40 or 70-30, which you do in machine learning, till now what we have done was 70-30, 80-20. That's fine with machine learning algorithms. But once we start with deep learning models, in deep learning models, we will have a lot of data sets, right? And if we have a lot of data, if we have a lot of data in that data set, we should try to have 95% in training data set and 5% in test data set, or 98% in train data set and 2% in test data set. Okay, more the data you keep, because now you have the liberty to keep a lot of data in your training data set, because for 1 million samples, if you take 1%, that would be like how much? 10,000. So 10,000 are quite sufficient in your test data set. Here, you had the data set of 10,000 samples. That was the reason we were splitting into 70-30 ratio. But here we had around 1 million samples. So 1% would also be like 10,000. So you can keep that into test data set and the remaining can be in training data set. Okay. Now, as I've already told this, the light blue colors are say that this belongs to one class and this dark blue color belongs to one class. And if I split that using this linear line, what I'm trying to do is I'm underfitting my model, because you should notice that I have some misclassifications here in the first figure. That means high bias. That is also called as high bias. In the rightmost figure, what I'm trying to do here is I'm trying to classify all my data with zero misclassification rate. So in that case, what I'm doing is I'm complicating my model. When I'm complicating my model, this might work very well for the training data set, but might not work quite well. It might not be able to generalize for test data set. That's the reason it is called as overfitting, and that is also called as high variance, right? And now, as I already told, this is just the middle graph is a just right optimum one. Okay, neither underfit nor overfit. The next point is, so far so good. Any doubt, guys? Okay, so when I have already told you this, if I'm not wrong, if you have a model underfitting, then try to complicate your, or try to come up with more input features in your machine learning model, right? But in your deep learning, if you are facing with high bias, which is underfitting, which we'll again see in third course, you have to have bigger network. That means more number of hidden layers. Okay, so always remember this: when your model is underfitting, try to complicate your model so that it goes from underfitting to optimum model. If your model is underfitting, try to less complicate it, as you can see in the figure, these three figures what I am showing here. In these three figures, as we can see, underfit is a very simple. Try to complicate it so that it can go to the optimum figure. If it is overfitting, that means highly complicated. Try to complicate it quite less, in simple English. So for machine learning, we have already seen, if you are underfitting, then increase the number of features. And if it is overfitting, try to use some regularization techniques or some other, try to get more data in your training data set. Similarly, here also in deep learning models, when it is high variance, try to train your model with more data at the training period or some other regularization techniques. Okay. If you are facing with high bias, then try to complicate your model. Complicate in the sense, have a bigger network. Okay. And again, this is the error values which I've already talked before. If so, this we have already talked, so I need to correct this. There is some mistake here, I believe. Okay. So meanwhile, so far so good. Variance and high bias thing, I will correct it. Okay. These are actually image, so I'm not able to do. Ideally, this is low. Okay. So I tried correcting it, but then this is image. So yeah, so what I was telling is, see, these are the error values. I'm just trying to tell the same thing here. When you have, these are the training, let's say these are the training errors, these are the test errors. Okay, so for training, if you have 1% error, ideally, if your error value for test is very high, then it is overfitting, right? That you have already complicated your model for the training so that your training data predicts your output quite well, but then you are not able to generalize that for test. That's the reason it is a overfitting or high variance. Similarly, if your training data set error is quite high, assuming that human gets 0% error, then this would be quite high, right? And this is quite high. And if your test data error is 16%, that means the difference here is very less. But this difference and the difference with human error is quite high. That's the reason it is underfitting, because your training is not behaving quite well. If your training data set is not able to predict your output well, forget about test data set. So it is underfitting, okay, or high bias. Now in this case, if you notice, your training data set is 15%. If I compare that with, say, human error, which is say again 0%, and then between this, the difference is very high. So this is already high bias, which is underfitting. And then the difference between these two is also very high. So this is also overfitting, that means high variance. Okay, so high bias and high variance. Now, in this case, if you notice, the error between human percentage, the human error is say again 0%, and the difference between the training error and human error is very negligible. So it's a low bias, which is not underfitting. And then the difference between these two error is also very small. So it's a low variance also. That means neither underfitting nor overfitting. So this is a just right model. Okay, so here it is training error, this is test error, and this is low bias and variance. Okay, this is how it should look like. Okay, so I will be changing this, apply up ANN. This is ANN is artificial neural network to the same data set, but I'll be changing this challenge for this. I'll be putting some more challenges, so which will be quite theoretical and mathematical. I will be removing this because I don't want you to implement artificial neural network now in Python, because that would be anyways there in third course. Okay, so I'll be removing this, and I'll be putting some new challenges here, mathematical and theoretical challenges, and that I'll be sharing with Roshan again. Okay, because I have not explained you how to implement this in Python. Anyways, that's there in third course, so I don't want to do that now. Okay, so what we have learned now is machine learning. Okay, in the next course which I'll be talking will be purely mathematical and application of maths in machine learning. So what all we will be seeing, this permutations and combinations, probability in great depth, and then statistics, confidence interval, all those things we'll be noticing in then mathematics and applications. And then derivatives, backpropagation, gradient descent, log loss function for logistic regression. So all those things will be looking into this course, which is purely mathematical. So you have to gear up for that. Okay, I'll try my level best that you would love it. The maths is very simple, don't worry, but it's just that you might see the same equations repeating again and again with different subscript or superscripts. Okay, that's it. The equations are very less. Okay, you don't have to worry. And then in third course, we'll be looking at for deep learning. Okay, so this will be dealing with multi-layer feed-forward network completely. That one algorithm will be looking into that one algorithm in very great depth here. How to improve our deep learning model, what happens if it underfits, what happens if it overfits, how to play around with hyperparameters, how many hyperparameters do we have. So we will be looking that into great detail in this deep learning model. Okay, so all the machine learning models are covered in this, and we have learned supervised machine learning. So I'm just revising so that you all should be knowing this. We have looked into supervised machine learning model. We have looked into unsupervised machine learning model. Okay, so now important part, to achieve a job, if you do this course machine learning, which I've from last few weeks which I've been taking, if you do this course, you are good to go. Okay, you are good to go to fetch a job of machine learning. You can, if you start working, if you complete all your challenges, and projects, and get your doubts cleared while working on projects, then start building your resumes based on machine learning. And then based on this, you should be able to start with placements. So you should be ready for the job if you do only this course. Okay, but then again, if you want to get a good job, and if you love mathematics, and if you want to land up into a job which deals with a lot of maths, then I really recommend that you complete this course also and then start applying for a job. And there are a lot of companies which deals with advanced machine learning. So there we will be looking. If you want to complete this course and then start applying, it's up to you. But you can always start applying for a job as soon as you complete this machine learning course completely. Okay. Also remember that you have to do a lot of hard work. If you're not able to understand anything, please explore things. You will learn a lot of things. Okay. Spoon feeding will not help here. If I directly tell you the answer, then you will not learn a lot of things. Okay. So first, whenever you're stuck, try to explore it. Okay. Then only you will learn some more things. So, and one more thing which I wanted to tell is, once you complete these two courses, first and second, you should be so good in at least two algorithms. You should be very good in at least two algorithms, in and out, with concept, with coding, and then with mathematics. In that way, in an interview, you would be able to tackle all the interviews very easily. Okay. So whenever you're going for an interview, just make sure that you're very strong in at least two algorithms. Again, I want you to tell this: for any project which you are working, always follow these points, because these are the important points which I always explain to all my students. Import all the necessary libraries, which are NumPy, Pandas, Matplotlib, and then for confusion matrix you already know, and then scikit-learn, which has all the inbuilt machine learning libraries. And then import the data set using Pandas. Okay, and then do a lot of descriptive analytics. Now it's the high time that you should, whenever you get a data set, try to find the mean, median, mode, variance, standard deviation, skewness, kurtosis, and then try to plot different graphs such as scatter plot, histogram. It's always good to have a graphical representation, bar chart. Try to do that. By that you will try to understand the data in a better way. You would be able to digest the data in a better way. So that is something which you always have to do. Okay, EDA in between. And then splitting the data, I always tell my students, try with 70-30, 80-20, 90-10 in machine learning models. Try to do all three. Check which split is giving you better results. Okay, there is nothing harm. It's just a matter of one additional line which you have to run. Okay, and then train your model. Okay, try to train your model with all the possible algorithms which you can use. Okay, I believe that you must have noticed that I have explained decision tree, random forest, and this KNN only for classification, but this can also be used for regression, right? If you remember, I have told you in the class. So you have to look into those details also, how to use those algorithms for regression. Okay, I have explained you only for classification, because there are a lot of projects which are more with respect to classification. Okay, and then once you train the model, then do the predict it on test model. Okay, which is very important, and then check the score. And based on score, when you do the validation, it's not only accuracy, you have to calculate different parameters, which I always tell. such as precision, recall, accuracy, and all other parameters, and then decide for what all parameters are required for your project. Based on that only you have to evaluate. Sometimes your accuracy might be very high, but that might not be preferred, because the project which you are working might be clinical trial problem. For clinical trial problem, sometimes precision or recall will be preferred. So you have to check based on that. So I sincerely advise you guys that start working on all the challenges, complete your challenges, submit your challenges to the team. Okay. And I will change the challenges for week 12. That's all which I wanted to tell for in today's session. I will not be going into Python coding today because that would be slightly difficult. If I explain it to you now, it would be better if you look at Python coding in third course, into deep learning course. Okay, so any questions? This is a time where you can have some questions, and then in support sessions you can ask questions more on your challenges, because by then you will start working on your challenges. I hope you have already started working on your challenges, but still in the support sessions you have the advantage to ask a lot of questions on it from your challenges. You can ask a lot of questions from your theory part, conceptual part. But do you have any questions now? Yes, we'll be going yes, we'll be going into second course only after completing all the projects of your first course. Yeah, we have to make sure that your first course is intact. All your project works are intact. Complete all your challenges, submit it to our team. Then only we will go into second course. But it's not that we will be waiting for you guys, okay? So we can start the live sessions. We might have to start the live sessions, but I think the recordings will be provided to you if and only if you complete all the projects, because that would be really difficult. If you don't submit the challenges for first course, it will be really difficult to get a mathematical understanding of second course. So please start working on this, all the challenges, but I'm pretty sure that you would be having at least 10 to 12 days from now to complete all your projects. And I'm pretty sure in Python also by now you have already understood it's just a matter of changing of lines. Like for example, if you have written a code for say logistic regression, you have to just change from logistic regression to SVM. So coding part should not be a difficult task, but understanding the data, which is more important. Looking forward for your challenges answers, and then meet you again. See you guys. Have a nice evening. Stay safe.